Welcome back to the review for the Chem 4 final, and we're going to start by reviewing the principles of Le Chatelier's principle. This is part 15. Now that we know what equilibrium is, and equilibrium means the rate of the reaction going this way equals the rate of the reaction going this way. We also know that at equilibrium, the concentrations of the products and reactants remain the same. But we can mess with that. And we're going to learn the different ways you can mess with equilibrium, the way you can change those concentrations. Remember, the only thing that changes K is temperature. These changes we're going to talk about now do not affect K. These are the steps for Le Chatelier's problems. And the way they might ask it, they might put Le Chatelier's principle in the name of the question, or they might say, what is the effect of ... adding more compound, taking away some compound. So if you see the words, what is the effect of, or what will the shifts be, they're talking about Le Chatelier's principle. So the first step I want you to do is cross out any compounds that are solid or liquid, because we know they don't really play a role in these problems. The second thing I want you to do is to add up all of the coefficients on the reactant side, the left side of the equation, and the product side, the right side of the equation. Now remember this. If you add or subtract a compound, or add or subtract heat, if it's being compound or heat is being removed, remember the words remove, restore. In other words, if I'm going to remove some of compound A, the reaction is going to shift to restore it. If I take away some of compound A, the shift is going to be left. What's the effect? A left shift. If I add more compound, remember, add, and then you're going to shift away from whatever side you're adding to. If I add to the product side, if I add to C, more of this compound, the shift is away, so that would be a left shift. If I add more compound B, add, away, that would be a right shift. We'll do an example in the next video, but one other thing I want you to know. If you increase pressure, you're going to shift away from the side of the equation that has more moles of gas. So for example, if I said 2A and it was a gas plus B and it was a gas makes C, which is a liquid, plus D, which is a gas. Remember, in our setup problems, we're going to add all the coefficients of the gases. How much gas do I have on this side? 2 plus 1 is 3. 1 plus 1 is 2. Oh no, liquids don't count, and liquid's not a gas. Step 1, cross out all the compounds that are solid or liquid. So we only have 1 on this side. So if I add pressure to this reaction, if I increase the pressure on the reaction, it's going to shift away. So that means, since this is more, we're going to shift to the side that has less moles of gas. You should also know that pressure and volume are very closely related. If you increase the pressure on an equation, on a reaction, you are decreasing the volume. So if I increase the pressure, I'm going to shift away from the side with more moles of gas. Or if I decrease the volume, if I put the same amount of gas in a smaller volume, isn't that same amount of gas going to be exerting pressure? The pressure is also going to go up. So you have to remember, if you decrease the volume, it's the same thing as increasing the pressure. So you shift away. Memorize one set of rules. You can always vice versa them if you need it. For example, if you decrease the pressure, it's the same thing as increasing the volume. Okay, you can do the complete opposite to figure out the shifts. One other thing. So we've done adding and subtracting compounds. We've done adding and subtracting heat. We've done, what else did we do? Increasing the pressure or decreasing the volume. The one other thing you should know is that if they say, what is the effect of adding a catalyst on equilibrium reaction? Catalysts only speed it up. Catalysts do not cause a shift in equilibrium. So you're not going to have more product at equilibrium or more reactant at equilibrium. It's going to stay just the way it is, same amount that's indicated by the K. So we're going to come back and we're going to do some examples of Le Chatelier's principle, and I'll see you in the next video.